In this video, we will review how to find the value of any trig function given one trig function and the quadrant. In this case, we are told that angle alpha is in the second quadrant. So here we are in the second quadrant. If you make a little triangle out of it, then you have x, y, and r. Now, in terms of x, y, and r, we know that cosine is x over r. R is always positive, so this negative sign must go with the 4. So that tells us that x is -4. We need to find out what y is, but we know that r is 5. So we could use the Pythagorean theorem, or this is one of those triples. There's a 3, 4, 5 right triangle. So since this is 4 and this is 5, then I know the y value has to be 3. In fact, positive 3 because it's up. So now we have x, y, and r. So I should be able to find the cosecant. We know the cosecant is the reciprocal of the sine function. So since sine of any angle is y over r, then cosecant is going to equal r over y. So in this case, that's going to be 5 over 3. Okay, so for number 2, again, we're in the second quadrant, and again, we need to think in terms of x, y, and r. Now, tangent is y over x. I know that y is positive and x is negative, so I'm going to look at this as positive 7 over negative 2. So here we have 7, and x is -2, and we need to find r. So we can just do the Pythagorean theorem for that. So r squared will equal x squared plus y squared. So that's going to be 4 plus 49. So that's going to be 53. So r is going to equal the square root of 53. Okay, so now we have x, y, and r. So we're supposed to find the secant of angle beta. Secant is the reciprocal of the cosine function. So we know that cosine of any angle is x over r. So that means that secant is going to be r over x. So in this case, that's going to be radical 53 over -2. So now we're going to do the same thing, but using the sum and difference formulas, which look like this. Now, for angle A, we're still given a trig value and a quadrant. They're just giving us the quadrant in a weird way by saying angle A is between pi and 3 pi over 2. Well, that tells us that we're talking about the third quadrant because that's between pi and 3 pi over 2. So let's draw a quick sketch into the third quadrant, which is going to look like this. Now, tangent is y over x. So that tells me that the y must be here and the x must be here. But in this quadrant, these are both negative. So this is really -4 and -3. Okay, so we're going to need the r value to evaluate some of these things. This is one of the famous Pythagorean triples. There's a 3, 4, 5 right triangle. So I know that this r value is going to be 5. If you did not know that, you would just do the Pythagorean theorem. So now, the formula for the sine of an angle minus an angle looks like this. It goes sine cosine minus cosine sine. So that's what we're going to do. We'll do sine of alpha cosine beta minus cosine alpha sine beta. But wait a minute, so far I've only drawn the picture for alpha, and I'm sort of forgetting about beta. So here is alpha. I'm just going to label that in case we have to refer back. But we should go ahead and draw the picture and everything for beta now. So beta is between pi over 2 and pi. So that tells us that beta is in the second quadrant. So that's why we'll draw our terminal side of an angle into the second quadrant, make a triangle out of it. Now this time they're giving us cotangent. Tangent is y over x, so cotangent is x over y. Now I see the 5 and I see the 12. So the 5 would have to be negative because it's to the left. The 12 would be positive. So I'm going to look at this as negative 5 over 12. We need the r value. This is another one that I have memorized. There's a 5, 12, 13 right triangle. So if you didn't automatically know that, just do the Pythagorean theorem. So this is a diagram of angle beta. Okay, so now we should be able to start finding these values. Okay, so the sine of alpha, that's y over r, so that's going to be negative 4 over 5. The cosine of beta, that's x over r, so that's negative 5 over 13. Now we need the cosine of alpha, negative 3 over 5. And we need the sine of beta, 12 over 13. So the rest is just a matter of simplifying this expression. So this is going to make positive 20 over 5 times 13 is 65. And then here I'm going to have minus a negative. Minus a negative is a positive. So this is going to be plus 36 over 65. So when you add these together, this is going to make 56 over 65. And that's going to be the answer. Problem number 11 uses the same two angles, so I don't need to redo my diagrams, but I just need to change my formula. Cosine of something plus something. That's going to go cosine cosine minus sine sine. So this is going to be cosine alpha cosine beta minus sine alpha sine beta. Okay, so let's see, cosine of alpha, so that's negative 3 over 5. Cosine beta, that's negative 5 over 13. Minus sine alpha, so that's negative 4 over 5. Sine beta, 12 over 13. Okay, so this is going to make positive 15 over 65. Again, minus a negative is a positive, so I'm going to add. This is going to be 48 over 65. So this is going to be 63 over 65. So that is going to be the answer. So number 12 will be very similar. Cosine of something minus something. This is going to be cosine cosine plus sine sine. So this is going to be cosine of beta cosine alpha plus sine beta sine alpha. So let's see. Cosine of beta, so I'm going to copy off myself. That was negative 5 over 13. All right, cosine of alpha was negative 3/5. All right, sine of beta was 12 over 13. And sine of alpha was negative 4 over 5. Okay, so that's going to make positive 15 over 65. And this is going to be negative 48 over 65. So that's negative 33 over 65. The next few problems are going to be very similar, except they will involve the double angle formulas. So first of all, we're given that the quadrant is quadrant 3. So go ahead and draw yourself a sketch into the third quadrant. We know that tangent is y over x. So that makes me want to say that x is 7 and y is 24. But in this quadrant, I know that x is negative and y is negative. So this must really be negative 24 over negative 7. We need the r value, so you need to do the Pythagorean theorem. Or if you've memorized the triple, I'm pretty sure this one turns out to be 25. But you can do the Pythagorean theorem to verify that. Now, the sine of 2 times an angle is 2 sine angle cosine angle. So let's just use that formula. So I've got 2 sine angle cosine angle. Okay, so this is angle A. So we're going to do 2 times, the sine is y over r. So that's negative 24 over 25. And then cosine is x over r. So that's negative 7 over 25. Now think of this as 2 over 1. So that's going to be in the numerator. So my denominator is going to be 625, right? Because I'm multiplying 25 times 25. In the numerator, I'm just multiplying 2 times 24 times 7. So that is 336. All right, so I'm not sure that this reduces. I'm just going to double check. No, that does not reduce, so that is going to be the final answer. Next, we have the cosine of 2a. For cosine, we have 3 formulas to choose from. I'm just going to go ahead and use cosine squared minus sine squared. So this is going to be cosine squared a minus sine squared a. Cosine is that negative 7 over 25. So that's going to be negative 7 over 25 squared. Sine is negative 24 over 25. All right, and we're going to square that. So that's going to give us 49 over 625 minus, let's see, 24 squared. That turns out to be 576, okay, over 625. 49 minus 576, that's going to be negative 527 over 625. So unless that reduces, then that's going to be the final answer. I'm just going to double check real quick. That does not reduce, so that will be the final answer. For tangent of 2a, I could use the tangent formula, but it will be easier to go ahead and use the fact that I already have sine and cosine, and I know that tangent is equal to sine over cosine. So I'm just going to do sine of, well, 2a over cosine of 2a, since I just found those two values. So the sine was 336 over 625. Okay, and then cosine was negative 527 over 625. Notice how the denominators are the same, so they're going to end up canceling each other out. So that's just going to leave 336 over negative 527. So that is going to be the final answer. Problem number 19 is slightly different and very easy. They're just asking, what is the quadrant of the angle 2a? So all we need to do is look at the sine of the sine and cosine, meaning are they positive or negative. So notice that the sine of 2a is positive and the cosine is negative. Okay, so the sine of 2a is positive and the cosine of 2a is negative. So that means that we're looking at a y value that is positive and an x value that is negative. Well, what quadrant does that occur in? Okay, well, y values are positive in quadrants 1 and 2, and x values are negative in quadrants 2 and 3. So the only quadrant that satisfies both is quadrant 2. So that must be the answer. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.